everyone, I am Carmen Gutib, and for our topic 1, let's discuss about the introduction to normal distributions and the standard normal distributions. So in this topic, we can learn in how to interpret graphs of normal probability distribution, and also we can learn in how to find the area under the standard normal curve. So last meeting, we discussed about the two types of random variable, the discrete random variable and the continuous random variable. So, the continuous random variable has an infinite number of possible values that can be represented by an interval on the number line. So, for example, the number of hours you're studying, so it's either between 0 to 24 since it is 24 hours in a day. Then, the continuous probability distribution is the probability distribution of a continuous random variable. So, therefore, the normal distribution, it is a continuous probability distribution for a random variable x. Then, the normal distribution, it is the most important probability distribution in statistics. So, the graph of normal distribution is called the normal curve. So, this is our normal curve. But in our normal curve, the properties are the mean, median, and mode are equal. But first, we will determine if where's the mean of in our illustration. So, this is our mean, the center of our normal curve. Next, the normal curve is bell-shaped and is symmetric about the mean. So, we see here that it is a bell shape. So, the total area under the normal curve is equals to 1. So, the total area of our normal curve is equals to 1. Then, the normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. So, our normal curve will never be touches to our x-axis even if it extended away from our mean. So, it never be touches to our x-axis. So, between our mean minus the standard deviation and the mean plus the standard deviation, in the center of the curve, the graph curves downward. So, this is our center. So, it states here that between our mean minus the standard deviation and the mean plus our standard deviation. So, the points at which the curve changes from the curving upward to the curving downward are called the inflection points. So, here, this one is called the inflection points. So, in normal distributions, we can have different values of our mean and can have any positive values of our standard deviation. And when we say about standard deviation, it describes the spread of the data. So, I have here an example. In our example, we can determine if which curve has a greater mean. So, let's identify. So, first, the curve A. Let's identify the line symmetry. So, this is our line symmetry of curve. This one, so it belongs to 17.5. So, here, our curve P, the line symmetry, is 27.5. So, in this illustration, we can determine if which curve has a greater mean. So, therefore, the curve that has a greater mean is our curve B. So, now, we will talk about the standard normal distributions. So now, we will discuss the standard normal distribution. So a normal distribution with a mean of 0 and a standard deviation of 1. So with a mean of 0 and a standard deviation of 1. Then, any x value can be transformed into a z-score by using the formula. So z is equals to the value minus mean over the standard deviation, or is equals to x minus mean over the standard deviation. So we have the properties of our standard normal curve. This one, the cumulative area is close to 0 for z-scores 2z is equals to negative 3.49. So, it belongs here. So, the area is close to 0 is negative 3.49. Then, the cumulative area increases as the z-scores increases. So, the cumulative area of z is equals to 0 is 0.5,000 or 0.5. So, kani siya, makita na to ni siya sa table nga iyang equivalent is 0.5 or 0.5 thousand. So, the cumulative area is close to 1 for z-scores close to z is equals to 3.49. So, close to 1. So, dili siya. The area is close to 1 is equals to 3.49. So, now I have here an example. For our example 2, we will find the cumulative area that corresponds to a z-score of 0.02. What you're going to do? First, you will find 0.0 in the left-hand column, this one. Then, you will move across to the column under 0.02. So, this one. So, we find it. So, it's 0.5080. So, that is already our area. And that's how we are getting the area of the value of our z-score. So that's all